So maths is all numbers, but we have words. How do you think ChatGPT understands these words?
Okay.
This is called one-hot encoding. In both the cases, we are not taking semantic meaning of the word.
Oh.
You can actually type it and see. Now I am moving from male to female. So we are talking about a small neural network that is supposed to understand the meaning of these words. This first neural network. And
Vector database. This
Yes.
is something new to me. Never heard about it.
hello, Papa.
Hello, bache.
So I have a question for you.
Again a question.
Yes. So you know that ChatGPT deals with words, simple language, English, right? How we generally talk.
Yes.
But whenever we talk about how things work internally, especially when we learned about neural networks, you remember that everything is maths internally.
Yes, you
correct?
taught me something.
Yes. So maths is all numbers, but we have words. Then what?
Now this is a googly for me.
Yeah, okay. So now I have this question that how do you think ChatGPT understands these words? Can you think of any way roughly that how can we represent words as numbers?
Is it getting converted into numbers?
Yes.
Words are getting
Yes,
converted into
exactly.
numbers?
That is the goal, that words should get converted to numbers. But how do you think it might be happening? Can you guess like anything, like any simple way of converting strings to numbers?
I'm sorry.
Okay, let's take very simple way right now.
Yeah.
Okay, so before we move ahead, I would like to ask you if you know that in our Educosys GenAI course, I didn't just cover the application side, but I also covered the basics of GenAI. So neural networks, RNNs, LSTMs, we literally wrote the transformer code, went through the white paper, went through the DeepSeek white paper. We have done so much. You have to check out the testimonials. Plus, if you're preparing for interviews, then I have courses on DSA, LLD, HLD, we have courses on C++. There is so much. You have to check out the testimonials at least. Even the LinkedIn profiles of all our testimonials are added over there for credibility, right? So you should know that if you like my teaching style, I love teaching over there. We are building a great community and so many people are already part of it. At least check out the details in the description. Suppose we have a dictionary. There are limited number of words.
Okay.
For now, let's say there are 1,000 words.
Okay.
Okay. So what if I just put numbers?
Assign each number a word.
Each word a number.
Oh, yeah.
Right?
Sorry.
Like, so 1, 2, 3, 4, 5, 6, 7, 8, 9 and so
Okay.
until 1,000.
Okay.
So that is one way.
One way.
So what you're doing is for every word you are putting a label or an index.
Okay.
Right? That is correct.
Okay.
So suppose cat is 2, car is 3, but say dog is 10, something like that, right? So every word will have a number.
Okay.
That is one way. But what problem do you think might happen over here?
But there are billion of words.
There will be limited number of words. Even if there are many words, there will be limited number of words. But still there is one problem over here.
Like say cat. If we expanded caterpillar, is it going to create some problem?
Not exactly that. Okay, so see, caterpillar and cat can be different words. So they will have like different numbers assigned to them.
But since the computer reads only cat and then assigns the number without reading it further.
Let's say there is space, so it is able to understand that okay, this is one word, this is not one word.
Okay.
Okay, let me make you think a bit. So suppose ChatGPT is there, and suppose when I say, oh, I am very happy today, okay, and suppose I am very excited today.
Yeah.
So it should understand that happy and excited are similar words.
Synonyms.
Right, it is synonymous,
okay,
right?
yeah.
Similarly, when I say I love cats or I love dogs, it knows that I am talking about animals.
Pets.
Right, I am talking about pets. So it should have some idea that these words are similar.
So these can be stored in a category.
But then like that, there are so many categories. Like for example, if I talk about cat and tiger, they are similar in one sense, but cat and dog are also similar in another sense, right?
Yes.
Similarly, human and monkey are similar, but they are not like, so how do you really capture how similar these words are? Because what you did, we took every word and then we ended up assigning each of them a random number, right? So now we have not essentially captured the meaning of those words.
Okay.
You understood the problem?
Yeah.
That, so this is called, we haven't captured the semantic meaning, the meaning of the word. What, so if I say I love eating, then I love eating and then mangoes, right? So you should understand that love is a positive thing. So if I say I'm excited to see mangoes, it is a similar sentence compared to I don't like mango. So because there is don't, it should understand that the entire meaning should get reversed, right?
Okay.
So we have to understand the meaning also.
Huh?
Okay, understood the
Now,
problem?
how will it happen?
Okay, so first let's do a quick sort of revision.
Okay.
So what we started from was the goal is that we want to assign all the words some numbers.
Some numbers.
Right, so that computers are able to understand them and we are able to
store them in the computer.
Yeah, and we store them in the computer, right?
Okay.
So the goal is to represent words or sentences in numbers.
Yes.
Okay. Now that is called encoding. Encoding.
Basically assigning numbers.
Assigning
It's called
numbers.
encoding.
Yes.
Okay.
But there are many ways for this also. So one way that I told was that we can assign labels. That each word is going to have a index or a
unique
label.
number.
Yes. So suppose
1, 2.
cat is suppose 2, car is suppose 10,
10.
and dog is suppose
20.
20. Okay, like this. So how many number of words? That number of labels or indexes.
Okay.
That is fine, right?
Okay.
Another way, maybe I am just telling you that how else we could do encoding. For example, instead of with a single number, I assign something like this. Okay, I'm going to make a vector, or you can say 1D matrix in simple terms.
Okay.
And I'm going to put, suppose there are 100 words in my dictionary. Okay, so there will be 99 zeros and there will be 1 1. So this will represent that, okay, this is cat. Like this, there will be 99 zeros, right? But if there is 1 over here, it will mean that it is a dog. If there is 1 over here, it will mean that this is a ball or something like that, right? So every time there is 1, then we understand that, okay, this is this particular
Where the 1 is placed based on that.
Correct.
Okay.
This is called one-hot encoding.
One hot encoding.
But these are just different ways of encoding. But the problem remains same, that in both the cases, we are not taking semantic meaning of the word. We are not seeing that which words are similar to each other or which words are different from each other. We are still not taking care of that, right? So that is the problem that we are going to solve now.
Okay.
Okay.
Looks interesting.
So this is encoding when we do not capture meaning, and when we capture meaning, we are going to talk about embedding.
Embedding, okay.
So from embedding, what I want to do is that I want to capture meaning of these
Meaning
words.
also, okay, interesting.
Okay? So now let me tell you something even more interesting. Like this is a very common example in MLAI field. When you ask ChatGPT this, okay, you do king minus man plus woman. What should it give you according to you?
King minus man plus woman.
It should give you queen.
Wow.
Oh.
And if you actually give this to ChatGPT,
it happens this way?
Yes. You can actually type it and see. King
I'll
minus
do it
man
right
plus
after
woman.
this completion.
Yeah, sure.
Okay.
So when you do king minus man plus woman, it gives you queen. Why? Because it understands that, okay, now I'm removing the gender, the male gender. I'm adding the female gender. So what is the female gender of king? It is queen. So it should be able to understand that.
But this intelligence has been built into it, or the model has been trained that way.
Exactly. So that is what we have to learn, that how do we train our models to represent these words using numbers so that it is able to understand the meaning of it.
Okay.
Interesting?
And what is this called?
This is just simple English, right, that we are giving.
Okay.
But internally what we will be doing is, see, king will be represented by a vector. Man will be represented by a vector. Woman will be represented by a vector.
What about minus and plus?
So it is just understanding that, okay, we have to remove something, we have to add something. Let me explain it. Okay, let me give you some more context. Let's just clear this.
Please.
Okay. So the goal is that every single word that we have will be represented by a vector. Right? Okay. So let's take some examples. Let's say we have cat. Okay, and we have car, we have dog, and suppose we have bike.
Okay.
And monkey. Okay, cool. Okay, so this is going to be represented by a vector. So in order to understand that how we are able to see that, okay, cat and dog are similar and they are kind of similar to monkey but a bit far. Similarly, bike and car are similar. Even though cat and car look very similar, but they are not.
They are not.
Right? So how do we actually understand it?
Okay.
So let me give you some basic understanding on a higher level. Okay. think of that every number that is going to be there in this particular vector is going to represent some characteristic. Like for example, if I say that first is going to say, is it animal? Sorry, is it animal?
Okay.
So it will be 1 for cat, it will be 1 for dog, it will be 1 for monkey, but it will be 0 for bike and car.
Understood.
Right. Similarly, if I say, is it vehicle?
So
Okay.
0,
So 0, 1,
0,
0,
1,
1, 0.
0.
Right.
Yeah.
Similarly, if I say,
Pet.
is it usually pet? Okay.
So
So cat is a pet, car is not a pet,
0.
dog is a pet, bike is not a pet, but monkey is usually not a pet.
Usually.
Right. So you will understand that, okay, cat and dog are kind of more similar than say monkey.
Monkey. Okay.
Right. So this is how you have to understand.
Build logics accordingly.
Yes.
Okay.
This is how we will build logic that, okay, these words are similar and these words are not.
Okay.
Okay. And if you have to visualize it in a better way, let me help you even more. You remember coordinate system, right?
Yes, yes.
So do you know what are vectors?
Yeah.
You know what are vectors,
Definitely.
right? In coordinate system, do you remember that in physics we used to represent vectors like this?
Yes.
Like this? Yes?
X, Y and resultant.
Yes. So even like if I suppose take 2D vector, okay, 0, 1 and 1, 0.
Okay.
So you can think of it like that, okay, 0, 1 is over here, 1, 0 is over here.
Yeah, yeah.
Now, even though I'm showing it to you in 2D space, in reality, okay, the dimension of this vector is going to be huge. There are going to be many, many characteristics, like say hundreds or thousands of characteristics for every single word.
Okay.
But in order to help you visualize it, think of it like this, that cat, dog is going to be nearby, right? And monkey is going to be say somewhere over
Far
here.
away.
A bit far,
But-
not very far.
yeah.
But bike and car are going to be really far.
But car and bike are going to be near
To each other.
Relatively.
So they are going to be nearer,
Just change
these
this
are going to be nearer. So when we visualize, it is that the animals are going to be together, the vehicles are going to be together. So we'll understand.
But animals category wise can be a bit apart.
Correct. So now coming to the example of king and queen, right? So there is king and there is queen.
Both
so this
are
is one
human
vector.
beings. Yeah.
Yes. So you can think of it like this, that if this is king, this is queen. This vector, like the difference is basically telling that now I am moving from male to female.
Okay.
Right. So similarly, if I was doing something like if this is a boy,
And a girl.
then similar vector would go over here, which will give us that this is a girl.
Okay.
Right.
Yeah.
So you understand like visually how we are getting it, right?
Okay.
So now the goal is that in embedding, what do I want? I want to represent every single word in the form of a vector.
Okay.
That is the goal.
Okay.
Right. Now, how do we make our model do that? That now our model has to be smart enough to capture the characteristic of every single word.
Okay.
Now that is the next problem, right? So we are trying to embed our words into vectors and we are trying to achieve embedding.
Okay.
Okay. So one very common solution to this is Word2Vec, but there are many solutions to
What
find
is
these
vec?
embeddings.
What is vector?
Vector.
Okay,
right.
Word2Vector.
Yes.
Okay.
So it is nothing but a simple small neural network where we are making our model or
Understand.
neural network understand the meaning.
And learn it.
Yes.
Okay.
So we are talking about a small neural network that is supposed to understand the meaning of these words.
Okay.
Right? On a higher level, let me give you some idea of how we will understand, right? So in a neural network, you remember that there is one input layer where there are some nodes and then there are hidden layers.
And output layer.
Output layer, very good, right? And suppose I have something like this. I like eating mangoes. Okay?
Okay.
So usually between I and eating, either there is like or there is love.
Why have you drawn these two here for hidden?
So it can be any number of layers. Okay. So usually the more the number of layers, the more complex relationships we are able to understand.
About the number of layers, hidden layers you are talking
Yes, yes, hidden layers. So this is like every layer might try to find some more patterns or relationships, something like that, right? So we are supposed to understand that what will be the word in between I and eating. Can it be like, can it be love, it can be dislike, it can be hate, it can be anything, right? So we will feed in a lot of sentences to this particular
Input
to
layer.
our input layer,
Okay.
and it will try to understand the probability of the words in between. Okay.
Okay.
So suppose the output was like, love. Suppose I put read. I read eating. Is that correct?
No.
No. Correct. Similarly, suppose there is hate and suppose there is am. I am eating is also possible, right? So each word will, so when we get the output, remember there is one predicted output and there is one actual output.
Yes.
So actual output is based on what we are trying to, we are trying to predict this, like we are trying to achieve this,
Yeah,
right?
yeah.
But there's something that we will predict. So we are predicting probability of this. So what should be the probability of getting read? It should be
Zero.
very less. It should be near to
Near to
zero.
zero.
But this can be high probability. So it can be say 0.9 or 0.8 or something like that.
Yeah.
Right. So in every pass, in every training, what is going to happen is we are going to predict the probabilities and we are going to understand that how different it is from the actual probability that should be there.
Okay.
And based on that, you remember there were weights and biases.
Yeah.
Those were the parameters. So we will keep updating them and then we are going to find the differential and keep updating the values.
The weights.
Yes, the weights and the biases, so that we are able to find the correct parameters. These weights and biases are called parameters.
Okay.
So that we are able to train our models and understand the meaning.
Okay.
So slowly it will start understanding the semantic meaning of it. So internally this is what is happening. Internally it is all just neural networks.
Okay.
So even for representation it is first neural network and then we use these representations to find even more patterns.
But you are still complicating the things, but so far I have understood.
Okay, got it. Now there's just one more thing that I wanted to introduce to you. So in the starting, do you remember you said that, okay, we will represent these words as numbers.
Yes.
And then we will store them. That is what you said.
Yeah.
Right? So earlier, like when we used to not store the words as numbers, because with the rise of AI ML, this is more needed, right?
Okay.
Earlier, it used to be stored as it is or in some other format,
Okay.
right? So there were different kinds of databases or data stores where you actually store your data, correct?
Okay.
So now that AI ML has come into picture, generative AI, and we want the words to be stored as these vectors so that we are able to understand the semantic meaning of these words.
Okay.
So there is something called vector databases that are on the rise.
Vector database. This
Yes.
is something new to me. Never heard about it.
So what happens is that we basically store the data in terms of vectors.
Okay.
So we train and we understand, or we basically embed the words into vectors and then we store them in vector databases.
Okay.
So whenever we are dealing with AI, ML, generative AI kind of stuff, the kind of databases that are usually stored are vector databases. There are many examples, like this is too much for you, but just letting them know that there is ChromaDB, there is Pinecone, there are a lot of databases, and there are companies that are dedicatedly doing this, building vector database.
Okay.
So interesting.
Yeah, looks to be interesting.
So did you enjoy today's video?
Definitely, as always.
So what did we start from? What
You
was the
started with, suppose there are some words which are to be, now we want to understand, like as you gave some examples of cat and dog. They are similar, they are pet animals, but cat and car are two different words. So each word is, say, assigned a number and then it is stored. Now that you called it as encoding.
No. Encoding was before we understood the meaning of the words.
Okay, before we understood the meaning of the word, it was encoding. Only assigning a number.
Only assigning some
Only
numbers.
assigning a
So
number.
remember labels,
Yeah.
we were assigning a one-hot
Okay.
encoding. So that was before we could capture the meaning.
Okay, that
Once
was encoding.
we capture the meaning, that is called
Embedding.
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 Very good.
So we spoke about the encoding, then we spoke about the embedding, then you came to the neural networks, you came to the input layers, then the output layers, and then the hidden layers.
This is all neural network only.
Yeah.
And so neural network is to achieve embedding, to
embed.
actually embed.
Embed. And then you spoke about the vector databases. Like you gave some certain examples of I like eating mangoes. Now this is to be to increase the probability. We have to assign various weightages and all, and
To not increase the probability, to assign the correct probability.
correct probability, and so that it is very near to the actual one.
Because see, read will be less probability, so it has
In
to
the
be
sentence,
near.
read.
Yes.
Yeah, it will be almost nil probability, whereas like, love, hate, am could have a high probability.
Good.
This is what you.
Okay.
And then
In
you
vector
spoke-
databases, what do we store?
We store basically to understand the semantic part of it.
We store the embeddings.
Embeddings
Right.
to understand the semantic part of it.
Correct. And if I have to visualize these embeddings, I can visualize it in a like coordinate like a diagram, and the similar words are going to be nearby. to each
Nearby,
other.
and the relation will be understood by that.
Very good. So now we have to tell them to.
Like, share, and subscribe to the videos.
Very good. Now he is telling you have to do it, right?
Thank you.
Thank you. Bye.
Bye.